Well, hey there, everybody. So today we're going to work on Chapter 15, and it's only 2 assemblies, but they're going to be quite time-consuming. And so we'll have these parts to model, then it'll have to be assembled, and then it requires a set of detail and assembly drawings. So it's going to be what looks like not a lot of work, but it's actually going to be pretty time-consuming. So we'll go ahead and get into it and start off with this base plate. And it appears it's millimeters, so make sure you're on your metric templates. And I'm going to draw these in the positions they're shown, except for this one. I'll probably do this one to correspond with this part, so I'll draw it on the same plane as this one. So I'm just going to draw on the front plane, and as always, I'll just draw a rough profile. Make sure you're doing vertical lines and horizontal, that way we get those implied constraints in there. And then I'll just draw here and trim off the rest. Alright, so then we have fillets on both ends, so we can go ahead, and what I'm going to do is just slap in fillets on all of them, and then I'll set dimensions after. So for now, I'll do an overall width of 160. And then we have 2 for this one, and 10 for the outside ones. But earlier, when I put in my fillets, I actually should have done 2 features. So I'm going to undo and do 2 sets. There we go. Okay, so just so we get our scaling right, we'll go ahead and delete this back out, put in 160, and then I'll do the 2 and 10. And then we have a width of 10 here. And it looks like it's 30 overall for the height. And I can go ahead and say that this portion equals that. And it's 10 here as well. So I'll set that to equal the 10 dimension, that way they're always consistent. And that may be it for this view, so let's go ahead and give it a constraint. So because I know that this part is going to be constrained to the other ones, I'm actually going to use the inside here, the center of that, to be coincident to the origin. And then the last thing I do need, assuming this is the same height, and it is, I just need to set these 2 lines to be collinear. And then I can extrude both ways with our value of, let's double check that, I believe that's the 75, but yeah, 75. And obviously that makes sense because half of that is to the whole, so 75. And let's see, so we'll go ahead and do this hole here. Alright, and it is 37.5, like we were talking about a minute ago, which is half of 75. And then it's 60. It's really hard to tell, but to me, that reads as, I think that's to the outside edge, because, well, I don't know. Let me think about that for a minute. So if we had 60 here and we assume it's 60 there, 10 and 10, that's 20. That'll only be 140. Let's do the outside edge. It visually looks like it's probably that, and there's no reasonable math that says it's one or the other. If we end up having to change that later because we see something in the assembly that says, hey, this doesn't line up, then we'll change it then. But for now, we'll roll with it. And we can go ahead and just do a cut. And then we'll do this little portion here. Y'all can hear that, it's my cat in the background. Apparently it's time to party. Okay, so we'll go ahead and constrain this together so it doesn't blow up when we start putting in dimensions. And it's going to be, let's do a diameter of 11. And then it's 10 from the top. And 37.5 to here. All right, so we can do a cut to next. Okay, so that's going to be the base plate, and I'm just going to go ahead and make a folder section real quick. And we'll do another series of them. I believe this is the leveling assembly. Yep, okay, so now I'm going to make my part the base plate. Alright, so we'll go ahead and jump to the next one, which will be the sliding block. And just to make sure I'm drawing it on the correct plane, so we have this one here. The block is going to be the middle piece, so it's going to be slanted down in that same view. So really it needs to be drawn 180 degrees to this. That's going to kind of be a pain for some people, so I think that I may just draw it with this as the front view, just so that it's not overly complicated. We'll just see where this lands and go from there. I think it'll be fine. Okay, so we've got a slant and then a horizontal and whatever, something like that. Okay, so then we'll trim out some of the goods. And man, some of this is just really tiny. Alright, so it's going to be 6, 15 for the angle, 25 overall height. That's okay about the dimension. We'll deal with that in a minute. And then 100 overall width. Okay, so it flipped itself actually. That's pretty cool. That may be it. I guess now I kind of need to choose a location. I'm going to actually choose this point to be coincident to the origin, just because, I mean, like, you kind of have this hole, some intents for it, so it's fully constrained now, so we'll go ahead and extrude it. And it's going to be 90. I guess the next easiest thing to do would be to draw the hole and this cutout on the bottom. Oh, that's the wrong face. And I'm just going to go ahead and draw an arbitrary rectangle and a circle. And our circle is going to be 10 from the bottom of that edge. So we'll go ahead and do the edge first. We're given 77 by 3. And of course it's centered. So we can go ahead and choose one of these lines, the center point of it, constrain it to the origin, and then I'm going to do a collinear on the bottom. So now I can go ahead and put in that 10 dimension we had a minute ago. And I believe it was also 10 in size. We'll double check that. Yep. Alright, so then we can go ahead and extrude these both out. Okay. So now, obviously we have a cutout, but we've got that back drawn. So we can do a little, I guess we can do a bottom view. And it's going to be, your typical lug style shape. Okay, so put in our constraints. There's no way that just perfectly touches it. Well, apparently it does. How about that? Okay. No biggie. Alright, so we've got a... Oh, I was wrong. It actually went to the center. We have a value of 45 and 50 and a radius of 16. So immediately you probably notice this line is not parallel to this line. You could also do a horizontal constraint or something like that, but oh, this one boils back to my own goofs here. It actually says I have something not constrained. Well, this is peculiar. There we go. I thought it wasn't coincident earlier. Okay. I tell you, sometimes it just constrains it a little too close, So now that we've got that, I actually still do have to go back in here. So I turned this line to construction earlier, but it didn't allow a closed boundary at that point. So make sure it's not construction there. Okay, so now we've got the part itself. We just have to add in the fillets. And they're a radius of 3. And let's see, so we have the vertical edge here, and on the back we've got this edge and this edge and that edge. Just double check here on the front. So also we have this edge and that edge. And that looks to be it, actually. Let me just double check. There's not one here. Yeah, okay. So we can go ahead and save this part as sliding block. And we'll jump to the lifting block. Now this part, it's a little more complicated, but nothing crazy. I do want to make sure there wasn't like a whole like thread node or anything. Okay, there wasn't. Our fillets node is up here, but we'll go ahead and start. Alright, so this will be our front view. And it's pretty much like the other one as far as form. Oh, when trimming goes bad. Okay, so we have an overall width of 100 never do that button. It's 7 tall. .25 tall. An angle of 15. And let's see. I'm not sure which plane we'll use. I guess we can. We'll make this point here coincident to the origin to fully constrain it. And its width is 100. All right, so then we have, it's kind of hard to see here, but it looks like a boss coming out the top with a hole through all. So we'll go ahead and draw that. Okay. Okay, so for a minute I was actually thinking that this 100 dimension was part of a diameter circle because it just happens to be right over the diameter dimension, but it's just the width. That's poor dimension placement. So it is just an 85 dimension diameter with a 32. So I can go ahead and slap those in. And then it's 50 by 50. So I can slap those in as well. And then we can extrude up 5. Turn on our sketch visibility so we can reuse that feature for sketch. I'll turn that sketch visibility back off. Okay, so now we just need a cut and we can add in our fillets. So this one's kind of tricky, but what you want to do is draw on this plane, and we just need to project these edges. I'm not sure how far it goes yet. I'm kind of just drawing these on the fly, of course. Okay, so it's 92 by 2. So let's start by offsetting this edge, and I'm going to extend this back because this part wouldn't exist, nor would this. So I'll extend here as well. And I'm just going to slap in a very generic 2. And if you've got all your stuff projected, then you no longer need to add anything. So you can just do the same as I did and just get to cutting. So it's 92. And you end up with a nice little shape like this. So then you just need to add fillets of 3. Okay, so clearly we know we need this one. Appears we pretty much need every edge on this one. Okay, so we've got that one, that, and here. It's going to be here, there, and it's going to be the same on the other side, of course. Make sure we got all of our edges. Okay, so basically anything that touches. Now, since we're going through here, I guess I could look at this edge, but I'm going to leave it not filleted. And we can save it as lifting block. Okay, so next we have the adjusting screw. And, you know, it says here use the threads or coil command. So basically, I could draw this part and make real threads, or I could just do an image of a thread. And, you know, either one would be fine. I'm going to do the image because it's really not common to do actual threads in a model because it gets to be too graphic intensive pretty quick. So we'll draw this, and I will kind of mention the cool command just so you can see how it works. There are times where it's cool to have it, you know, and you're welcome to give it a shot, but you need to know a lot about threads that you don't necessarily know at this point. You know, you have to know the root and crest and where to actually locate that profile that you're revolve cutting or adding, depending on which way you want to use the coil. So, yeah, we'll go ahead and draw this. And it's 72 long, noticed. And I'm going to do this as the front view. And of course it'll be a revolve, so I'm going to do basically that in half. Okay, so we've got a very long shaft. It's probably good not to make everything in line, or it may imply some constraints. I'm just going to trim out some of this to make sure it's uneven. Okay, so overall 72. I'm going to make this line center line and make the midpoint coincident to the origin point. We've got a width of 12, 11, and 5. It's kind of hard to see this. So this is 14. The diameter is 10 for the actual screw part. And this middle portion is 10. And this is 16. Okay, so you know, we've got a head hole, so we can draw this portion, go ahead and revolve it. And I could add the chamfer in here, but I really like to have my chamfers elsewhere. So it's nice to have it as a feature. It's really easy to add and you know, manipulate later if needed. Okay, so we'll go ahead and do the hole on the head. And let's see, hex socket, flat to flat 10, depth of 9. So I'm just going to draw a polygon. It's already set to 6, and the flats are horizontal in this view. So I'm just going to make it horizontal, do that flat to flat value of 10, and then extrude it a depth of 9. Okay, so now we've got a nice little hole. I'm going to go ahead and just talk about the coil feature in case you do want to use it. You know, it depends how you want to go about it, but it's usually a lot easier to draw a triangle that is cut in half here, and I'll just show you roughly how it would look. It's not something I really would advise doing right now, just because, like I said, you really don't know what you're doing at this point. But you know, you never know. You might like what you see when you do it and go for it. I don't know what the height is, so I'm just going to give it a value of 1. And then, like, so for instance, I could do a coincident for this point to these two edges. Okay, you know what? We'll just do a collinear here. Okay, so now say I had this. I could do a coil command, and I could choose an axis once it chooses that profile. And I don't know how long this was, so we'll just say I have 10 rotations of this. And obviously that's super long, but it's fine for the sake of showing this. The pitch would be whatever the actual width is. I didn't measure, but I'm guessing it's 1 since it looks to be equal in size. So I could go do like 20, 40, 45, whatever. So it's like roughly 44. So when I do that coil command, it also actually is preferred to go further, and I forget that it has this little extra portion. So really, instead of halfway, it's a little bit easier to, let's delete this line, delete that constraint. Okay, so it would be better in this case to start it with this corner completely in the head. And basically what that enables you to do is start completely in a model, so there's no like transition. You see that line right there, and hopefully this doesn't crash my computer like it's acting like it's going to. Whew, it's really thinking, wasn't it? Okay, so yeah, now we've got this perfect transition, and it looks nice. But, you would have to do the math to make sure it's not too big as it is now, and you want it to come out perfectly at the end and all of that. You would have to do like a chamfer on it, and it's quite a bit of work for somebody that doesn't know anything about fasteners. So it's a cool command, and you could also just cut away instead of adding like I did, but that's the general premise behind it. I wouldn't advise it. That's for down the road. So for now, let's just do a thread command, and it's going to be an M10 by 1.5. And we want it to be from the other end. I've noticed the tool is kind of finicky about that. It's all about which end you click on. So like if I click on this side, it starts there. If I click on this side, it starts here. So it runs the full length, but in case you don't have it set to full depth, that's one of the things you need to know. So it's M10 by 1.5. So then the only thing we're missing is our chamfer. And the reason I put the chamfer after is because it avoids, if you have to adjust it later, it not knowing where the correct end is. So I would advise doing it after the fact, always. And we only have to put in a length because it's a 45-degree angle. So yeah, that's it. So we'll name this adjusting screw. And then we can jump into the basic motion analysis. So we make an assembly here and slap it all together, and then I believe we do the analysis. So let's just take a look and make sure. Yeah, okay, so cool. We'll just need to do a drive constraint, animation, interference analysis. I'm going to go back to the assembly so I can see what I'm slapping together here. Okay. So first of all, I'll just do a place and choose all of our hoopla. Just paste it all in. Hopefully nothing was grounded. I don't see a ground symbol, but just to double check. And I'm a little petty. I like to have shaded with edges on, so I'm going to go in and change that. Now since this is our base plate, I'm going to use it as our foundational piece and constrain it to the origin. So I'm going to do XY to XY. Hopefully each one of these planes should correspond pretty well, and they do. That's the perk of drawing it on the same planes as the origin plane. It tends to be a lot easier to work with for sure. Okay, so next is this guy. I'm just going to move some of this stuff out of the way as we go. Alright, so this one resides here. And then, let's see, so it mentioned analysis, but I didn't really pay attention to which parts. So between the sliding block and the base plate parts. Okay, so that's the lifting block. Okay, so yeah, this is the one I need to do it on. Okay, so we will do a constraint from here to here, and that should serve as our one for driving a constraint. But we also need to do a plane that cuts them both in half in order to say that they're aligned. So, and that should be it. It'll be the one we drive later. Unfortunately, I constrained it backwards. So, I'm going to show you how to edit some stuff. So when I hit this, I change the selections, and then it actually, oh my gosh, I'm tripping. I'm sorry, guys. Okay, I had a right to begin with. No, I didn't. Okay. Sorry, long day. I'm going to delete these two constraints. Or I guess I could flip this one to be a mate. It's going to error out. I hit accept, and I'll delete this mate. Okay. Now that looks like it's supposed to. So now I just need to constrain this face to this face. And our hole lines up fine. Cool. And as you see, our groove fits. So I was just making sure. You never know with that kind of stuff. The one thing I hate though is like this. So like, there's this round portion, and it's really intersecting it. Like it's fine, I guess, but I think because of that, I'm actually going to make it drive from the other end. So we'll constrain it there. It's the same problem. Okay, so it's fine. We'll just leave it. Lord. Try to be a perfectionist. Sometimes it doesn't always work out. So we can constrain this face to this face. And let's go ahead and do the plain one first. It seems like a easier one to pull off here. Alright, and we're going to flip it. And really, like, it's kind of a tough one because, like, I want to go ahead and immediately put in joints, you know, and try to get it to position itself a certain way. But I don't think that the exercise really necessarily wants you to. So I guess what we could do is maybe try the same trick here. I don't know. I'd be lying if I said I was very familiar with the drive constraints. So we can see if that works out, and if not, we'll reassess them. And then I'm going to be a little lazy here and just do an insert to this circle, because that is always going to be in that slot. And then I can do, even though you won't be able to see it, I like to have everything where if you tug it, it doesn't move at all. So I'm going to choose the base plate and that adjusting screw and give them the same angle. So now, even though it's hard to see, if I tug it, it doesn't spin. So actually nothing moves right now. And unfortunately, I don't know what's going on here, but our home view is not set right. So I'm going to right click that and then set current view, fit to view. So now when I hit the home button, it saves right. And I'll make my leveling assembly. Alright, so let's play around with these drive constraints. Okay. So we do drive. Let's try expanding it. Huh. Collision detected. Alright, so how about we... I'm thinking let's not have this and let's see what it does then. I mean, because it spins freely, or slides freely, but that might be part of the problem with why we can't do it here. Alright, so collision detection is on. It does it again. Okay. not bad. It's definitely not good, but it's definitely not bad. So how about, can we possibly do, first of all, I want to see how far can this slide upon it. Pretty darn far. It's really to about there, I guess, that it goes. Yeah, so I'm going to try putting it back over here and see what that lets us do. I mean, that's pretty accurate. Let's see about this one. Yeah, actually, I like that. Okay, so basically we right click, drive, test play, and more or less what happens is it'll shift so far here or so far there. And honestly, I don't think that the book is really asking for much more than that. So, you know, what can you really do? Okay, so, yep. So that's fine with me. So let's go ahead and work on our drawings. And in order to do that, we're going to need to have ViewReps, of course. So I'm going to make 4 new ViewReps. And just name them. I don't know why it makes a default now. That's new to 2020, but I do not like that. Okay, so I'm just going to go through and isolate each one and lock it. Ah, thought I messed up for a minute. Okay. All right, so we can save that, and now we've got our various representations. So now we're going to go ahead and make our assembly drawing piece by doing an exploded view. So in the past, I did position reps, but honestly, they're not really great for a true exploded view. So this time around, we're going to do them the optimal way by doing a presentation. So all you have to do is choose a part and choose tweak components from the presentation panel tab, and it'll let you manipulate them fairly easy. And if you've ever used like Maya, this is pretty similar to that. And also SolidWorks kind of has a similar process. So I choose a part, choose tweak components, and then I can use these pieces of a gizmo and pull on it. And yes, it actually is called a gizmo. So I can pull these grips. I can also pull these planes to move in 2 directions at the same time. But note, I've moved it 3 separate times, so now I have 1 move, 2 move, and 3. So note, every time you pull it, you actually are doing something. So keep that in mind. So what I'm going to do is, let's see, how do I want to go about this? So obviously this one we can just bring up and over, and this one we can move up and not, that's too high. Okay, so let's do that again. What I think I'm going to do is basically just pull it up and slide it underneath it here. And I wonder if you can edit path here. Yeah, edit tweak. Okay. So what I want to do, I kind of want to move it over further. Okay, so that's fine. So now what I can do with this one is move it, because it's got to come up out of that. I can pull it. Oh, I accidentally clicked the wrong button there. So I can pull it up, and then I can pull it back. And you know, it's not like the greatest looking thing, but I mean, really, what else can you do with it? I guess I could redo. Dang it, I lost part of my tweak there. Okay, so that's fine. That make sure you're hitting the check mark when you do these, and don't hit that plane. So what I keep doing is accidentally clicking the wrong gizmos. You got to hold and make sure you're being more methodical about it than me. But this one, I'm going to delete this tweak, and then I'm going to edit this tweak, and we'll pull it up a little higher. Yeah, I think that's how we'll keep it. The trails are pretty obvious. I guess I could lower this one back down now that I've looked at it a little better. So anyways, now that I've got it set, I can save it, and we'll just call it leveling assembly exploded. It's really a presentation, but we're only really using it for that purpose. So now we've got this guy for our details, this guy for our exploded. We can make a pretty chill drawing set. So we'll start with the exploded one first, since it's kind of low-hanging fruit here. And basically it's saying, blah, 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 I'm going to make a snapshot for you. And it failed to do so. Interesting. Okay. Why you do that? Well, okay, so that's hilarious. I basically went through the same process and it just worked that time. So basically, though, what I did was I hit Create Drawing View, and it popped it into a new drawing, and it did the same exact thing that I was trying to do over here. So anyways, I can scale this up a bit, and we'll go ahead and put a title under it, Leveling Assembly. Make sure you're using all caps. And I will shift this down, add a parts list. And you know, in later classes we'll hunker down on BOM filling out, but for now, make sure you do have your BOM. And just bubble your items. And if there's an option, show your tweak trail. Let's see. There's no option for it, it appears. Yeah, show trails. Okay, so it's on. And I see them now. I just didn't notice them at first. They're here. So I'm going to move this over a bit. And yeah, that's the first one, actually. It's not too bad whenever you actually get into it. I believe it calls them assembly drawings. That's really what it is, but I just want to make sure we're keeping the name scheme the same as the book. Okay, so leveling assembly drawing. Seems silly, leveling assembly drawing, but that's what it is. So we'll save all that crap, and I'll close this one. I'm gonna go ahead and close the presentation since we're done with it. Okay, so now we'll do this guy. I'm just gonna look at the views and see what I like here. So first impressions, this view, pretty useless. I mean, honestly, it's all kind of not great. So I'm just going to delete this view, and we'll keep this one over here. So I'll turn on my view label, give it the name. And again, we need a parts list. And I'm a huge fan of like adding details for the assembly here and then bubbling here. You know, some people really don't care for ISO views, but I feel like it gives a lot more depth as to what you're trying to portray, even if it's not appreciated. It's good to do. You could have them in your other view too, but you know, it is somewhat redundant. So, and there's really not much you can do here. You know, it's obviously centered and positioned. So, I mean, if you want to throw in some reference dimensions, you could. I'm going to try to put in a few. I'm definitely going to put in center line. I really don't know what else you could do here besides that. I could put a center line through here, I guess, but I'm just going to generically expand this and call it a day. I am going to kind of do the same here and just extend this out. Just so it says, you know, like there's a hole and it passes through stuff, but it's really not great. And just to give myself some feeling of accomplishment, I'm going to give an overall and an overall at the least. Like, it's always good to know what you're working with. And let's see, we'll do the same here. Alright, so we have 4 parts, so I'm going to go ahead and make our sheets. And if you want to name these sheets, that's always plus too. And we'll go in order of BOM. So adjusting screw, then base plate. But you know what? Let's make it match the book. I take that back. Okay, so base plate and sliding block. So base plate, sliding block, lifting block, adjusting screw. And then we'll, dang it, I goofed. Undo that. Ah, would have been nice. Okay, so 1, 2, 3, 4. Okay. Dang it. I hate this. Okay. Alright, so let me just double check that since it keeps on wanting to go back. Sort by item number, hit OK. Alright, so just so I don't mess this up, I am going to rename these. Okay, so we'll place in our base plate. Make sure you've got this checked always. And you kind of really do need every view of this one. That way you can detail this and also that. I guess this is the least used one really, but I'm going to put on hidden lines. That way we can see all of our details in every view. It always helps a lot. And we'll just bubble each item in the ISO view for all of these sheets. Oh, that's weird. I could have swore I hit the center mark button. Okay, so we're just going to add in some center lines. And that one would kind of be a pain, so I'm just going to let that one be. I mean, I guess I could see if it gives us an edge. I mean, it does. Yeah, okay, we can work with that. Yeah, so perfect. Not at all perfect, really. Yeah, so that's a no-go. I'm definitely not going to put a wrong line. Okay, so now here I'm just going to use the dimensions the book gives. I'm not going to do anything crazy here. So we've got 10 and 10 here. And let's go ahead and change this before I forget. Let's see. And note how I'm keeping dimensions off the model. Please do the same. And make sure you've got your gaps. And really try to keep spacing similar proportionally. Notice how even this I kind of try to keep it in line, even though there's not like a great, way to align it. You can just do it by eye. And let's see. I like to do a diameter here, just like I did in the book, or the model itself. If you do it like this, then you know that the width matches. So instead of having to deduce that the radius matches the slot, it's easier just to give that one value. And I'm going to keep the dimension off the model. We're actually going to pull it over here. And I think that's it for this view. So we can go ahead and reposition things if needed. Maybe shift that over a bit, pull that down. Alright, so I'm going to flip this to match the book. All caps. I forgot something. No, I didn't. Okay. I'm going to turn on hidden lines here. If I click the right one. And I'm going to make this a bit bigger. Let's do 1.5 to 1. We'll scale this one the same. Alright, so got a 6. I think instead of this view, what we're going to do is a section view. Yeah, I kind of want it. Okay, I thought about it. I want to see that groove really well. And the only really, I'm thinking of the wrong part anyways. Okay, yeah, we'll just do it projected. I was thinking we were looking at the one with the 92 by 2. So anyway, so we've got 15 and like 100. I think it would make more sense to have a bottom view, as crazy as that is. Just because, if I dimension, well, I guess it's fine. They'll never know the difference, but really it's elongated here, because it's not true to size, but I don't think that it would show any difference in value. Come on, you. Yeah, so, tough call. It's really true to size here. Yeah, we're just gonna do it here. It's fine. Okay, and I'm just gonna, I guess, expand this, even though it looks silly. Okay, so pull this down, flip that up. What else? Not really a great spot for this. I guess we'll just flip this back down. Ah, come on, you. Let's see. I'm just making sure there's nothing else here. Oh, yeah, this should be a diameter for one. I don't know why it's pulling a radius there. That's fine. Also, it's actually from this bottom edge 10. So I'm going to manipulate that little grip. There we go. Good thing to double check that. All right, so lifting block. Oh wait, I'm missing one key thing. Let's do a leader text into our fillets note. Fillets and rounds R3. We get bold too. And a little bit bigger probably. Let's try 4. That's fine. Make sure it's centered and above the title block. Okay, so we'll do this position. And same deal, we're going to scale it to 1.51. Make sure hidden lines are on. Add in our center mark, center line, and let's section this one. All right, so we're going to break the alignment on it. Instead of having this useless view, we'll just have it right here, and I'm going to change its alignment to be, oops. I'm going to change its alignment to be horizontally aligned to the original lifting block. Unfortunately, I should have chose further for these, so I'm just going to edit that real quick. And delete my coincidence here. Come on, you. Yeah, so basically you generally want your line to protrude past your your actual feature. So what I was doing was editing the actual line. You can right click it and edit to do that. So anyway, now we have this juicy view to have our 2 value. And that, I mean, that's going to give you more information than anything else ever could. I mean, wouldn't you have liked that when you were drawing this? Probably. Okay. Go ahead and bubble this. All right, so we've got this guy and this one. We've got 50 by 50. We've got the width of 100. A height of 5. Height of 25. 7. Our angle of 15. You know what? We kind of needed a side view actually for, you know, we need this dimension. You typically don't want to dimension hidden lines. Let's see how goofy that would look with a side view. Man, it's unfortunate to have it. You know what I think I'm going to do? This is a little bit cheating, but let's do a leader. And let's just say that same note we had before, 92 by 2 cut. Totally cheating, but you know what? It would be kind of silly to have a view just for that. So, I mean, it's really not, but in this case, I just don't want it. This is a nice layout we have, and it's pretty uniform, so we're just going to roll with it. All right, so the only thing we still need is the width here of 100, and that makes me have to shift this out. So we'll actually put it here and bring this one in for the same reason, to try to make it a little more tidy. And we'll reposition it. We'll jump down to the last one. Honestly, this one could be 2, so we'll let it be 2. And let's flip the position here. We really only need 2 views since it's so basic. Oh my, I forgot a chamfer earlier. I just now realized that. Okay, so let's see, it was here and here. So unfortunately, that means that we need to update our assembly and our assembly detail and assembly drawings. I'm going to save this first of all before we get too far in the weeds. Detail drawing. And let's open that assembly. Oh, I'm in my downloads. Okay, so let's open our exploded and our assembly drawing and update those. Reason being is now, you know, there's a different part, it needs an update. So I can close that. And now this needs an update. I can save and close that. Okay. It's always good to keep your files up to date, especially when you turn them in. You don't want it to be jumping around when I get to it. So, all right. So, you slap in our values, and if it ends up not having enough room for the dimensions, we'll bring it out a little further. But this one's fine. I really don't typically like to have these laid out like this, but I don't really see much choice given our options. It's either here or on this side, so we'll roll with that. I guess I could space them out a little bit further. Let's see. Should be an option to show your threads in here. I don't see them, so there we go. Yeah, so turn on thread feature in your display options. Double click the view, display, thread feature. That way it implies there's a thread. And then I'm just going to do a leader. Come on, you. And I'll say, what do I want to say? M10 by 1.5. We'll do a chamfer. What is this crap? There we go. And we'll do 2 times since we have 2 chamfers. Oh, that's bad. Okay, so we'll put it in parentheses to make it a little more clear. Other than that, turns out we do need another view. Let's do this hex part. So suddenly now everything adjusts and we have a left side view. So I'm going to copy all of this, turn off this view label, turn this one on, paste it over, and now like that, this guy runs the show. But I want it to be orthographic still, so I'm going to position the screw like this now and delete this one. So now it's truly taken over the show. And then I'm just going to add in a center mark and put in our 10 value there. We really need hidden lines, so I'm going to turn that on. And then the more you look at it, you think, oh man, but I don't have a depth here, so I am going to section it. So just like that, the plot thickened quite a bit. And I'm just going to place it over here for a minute, and then I will do an alignment break. And let's see, where would we like it? You know what? That's what I'm gonna do. I'm gonna flip it. I'm gonna flip the direction, and we'll just have a depth dimension there. We could just have a note, but why not? You know, it's nice to know the applications, what you can do. So we'll have a section here. I'll pull down this so it's kind of not in the way. And why not? We'll just put this right here since we've got this all laid out. We'll do a bubble. Okay. We lost some stuff earlier when we added that chamfer, so that's what all this pink means. So just go ahead and grab and fix any of the ones that have the cyan mark. And that one just fixed itself conveniently. Let's pull that back up. Okay, so now we'll save that. And that's going to be it for this set of drawings. So we'll jump over to the next one. Alright, so our last assembly here is going to be the toggle clamp. And, you know, we've got the same deal. We've got to do the drawings, and we've got a few parts here. They're mostly basic after this first one. But obviously this first one is quite a doozy. And there's various ways to go about it, but what I'm going to do is draw this base more or less, and then we'll add in some flanges to do the rest. And first and foremost, of course, we'll set up our sheet metal default. So let's go ahead and try to zoom in a bit and look at it a little bit better. And it's inches, so that's cool. So make sure you open a sheet metal template, and we're going to draw on the top view. But actually, let's go ahead and do our sheet metal defaults. I literally just mentioned that and I forgot. Okay, so first and foremost, we have number 11 gauge, 0.125, mild steel. Should be called steel mild. Yep. Okay. Bend angles are 90. Bend radius is 0.5. The K factor, that's actually not the standard. It's usually 0.44. So, and standard OB round relief. So let's go back and choose corner relief shape round. Okay, so now we can draw that top view, edit my sketch that I had started, and let's see, so we had vertical line. It really was kind of like a shape like this. I'll just add to it in a second. We'll just draw and trim as always. Okay, so now I've got double circles. And I know that this circle is going to equal this one with that one. Odds are they're probably all, yeah, the same hole size. Dang it. Okay, so now we'll put in tangent. Sorry, just making sure I'm sharing. It's all too easy to forget if you are. Okay, and we can trim. Okay. So we have an overall of 4.5, but that's actually not to what we're working on, so that's unfortunate. Let's see. We do have a 3. And I see a 0.75. And we'll locate this point horizontally to the origin. We'll do the same with this portion as well. And this is 0.375. And I guess we're not given the radius on this side, so it's got to be the same. So I'll just set it to equal. And let's set these lines to equal each other so that this kind of repositions itself a little bit. We can do the same here. Get our angle of 60 in there. Two. .25. And let's see, what else? Let's go ahead and make this point coincident. This 4.5 dimensions is what makes it hard. Okay, so basically it's the thickness here to here that's the difference. So I can subtract 0.125 from the overall, and that'll give us our overall. So 4.5 minus plate thickness will put us at the end of that flange. And we'll double check to make sure that works, of course. And then we're going to do the entire middle portion that I forgot. And it's going to be a circle with basically a rectangle. And we'll probably have to put in some parallels or something because it seems like rectangles always like to break, but we're good there. Okay, it's fine. Alright, so then it's 1.1 to the end of that flange. That's a terrible position. I don't know if that one's going to stick. We may have to edit this one later, but I haven't drawn this before, so we'll just take it as it comes. Okay, there. You know what? There's a 2 value. That's great. Okay. And then we need to locate this to be in the center. And hopefully this value sticks. This is the one that's in question that may be problematic, but we'll just see as we get there. Ah, I knew somewhere. It always breaks on a rectangle. Okay, so it's perpendicular now. And I'm going to reposition that. And we'll put this over here to make it more clear. Okay, so we'll do a face. And let's go the other way. Alright, so from here, it's a decent starter. You know, it's not too bad. We've got a rough shape, so we just need to add in a bunch of flanges. So we'll do these 2 first. So I'm going to choose the edge, and it's set to be quite large apparently. I was sitting there thinking, how can the bend radius be so large? It doesn't appear to actually be 0.5. I'm just curious, is it 0.05? Yeah, it's 0.05. Did I read that wrong? No. Okay, so take note, everybody. Go back and for your bend radius, make it 0.05. Because that's gigantic on a part like this. And so we'll choose the flange again, and make sure you're choosing, thought it was right here. Oh, okay, it's down here. So expand this out, change it to width, because we don't want it to be the full width that's there. We want it to be 1.25 wide. So we're going to change that to 1.25. And then, I wonder if we can choose this other edge at the same time. Kind of. Okay, that's fine. You know what? We'll deselect that and it'll let us. Okay, well, bad moves, guys. It's fine. So expand it, width 1.25, centered. Make sure it's centered, and then we need a height of 1.3 plus the radius. So 1.3 plus 0.625 is 1.925. Alright, so 1.925 long, and then we want it to end where that edge began. So looking at it, it actually does, it appears. It didn't do round reliefs though. Weird. Wonder why it didn't do round reliefs. I wonder if we can do a corner seam after the fact. Doubt, but no. I guess we could try doing a corner around here. It's really not the goal. We might just roll with that. That's fine for now. Let's press on and see if this other side works out if we do that. Okay, you know what? It's because I changed it in the wrong spot. My bad. Okay, so we need to go back into our sheet metal defaults and change this to be round as well. There we go. Okay. All right, so now we can press on. And since these are the same, what I'm going to go ahead and do is cut out portions of this, and we'll just basically mirror it across that face. That way we don't have to work as hard. All right, so that is 0.625, and just to verify our values are correct, let's do a radius. F, okay. And it comes up to 0.625. Okay, so we can do a cut and trim the excess because Lord knows it's got to be a pain. Well, what we'll do is we'll just draw in this part. Make sure it's fully defined, of course. Make these two lines down here construction. So now when I choose cut, it'll only choose oh, don't you love it? Okay. This is one of those things where sometimes it's just easier to use extrude. I don't know why. It's like the tool itself can be very finicky, but if you use an extrude, it works fine and doesn't have problems figuring out the profile. So I may have actually put myself in the corner here, but I want to try to make a plane between this area here. Let's first make sure I've got the 1.1 value correct. Okay, so it's good. So I guess what I could do is 0.775 over. I can do a plane. So we can do 0.775 divided by 2. And that's going to be the middle distance between this and here. Yeah, cool. Okay. And just to verify, let's measure that, 0.775. And it should be 4.5 to the other end. Nice. Okay, so now it's starting to look like something. So then we can do a flange on this side, doing the same general idea really. And it's going to be how wide? It actually doesn't say, so that's interesting. It looks like it's auto projecting this. So let's just take a look at how this turns out and see. So the height itself would be 1.25 plus 0.3, so 1.55. I guess I could also just be safe, type it in. And we need it to be inside of the edge as well. So it is. So let's see how that does. Yeah, so that's perfect actually. So we can do the same thing and just project the face, draw a circle tangent on all sides. Or actually no, this one's not that way. I forgot. It's a little bit different. It has a slant. Okay, so 0.3 and 0.25. And it appears it has a bit of a lift before it comes over. Oh, okay. So it's just to the edge of that bend. So what we're going to do is draw a line, and we'll make this end coincident to that end, this edge tangent, and then let's just trim off the fat here. And then we're just going to do an extrude, cut both ways, and pick this extra bit. And I forgot a part. All right, so then we can just do a mirror of those two features using our origin plane. Come on, you. Okay, so let's just verify some dimensions here. Should be 1.25 there, and 0.75 between the faces, the outside faces. Let's see. Should be 1.25 here, from here to oh, it's actually here. So 1.1, 0.75, 775. And then 1.3. Yeah, okay, so this looks good. So we can go ahead and save this part as a new folder. Toggle clamp assembly. And it's our first part, the sheet metal base. The other ones are a breeze after this, so should go quicker. All right, so let's zoom this out. All right, so we will just do an extrusion and an extrusion, really like 3 extrusions in the chamfer. Sometimes I feel like you could do it more efficiently, and the option's just not abundantly obvious. So I'm going to start with the fork part though, and I'm just going to lazily draw the shape. Is this efficient? You know, honestly, not really, but it's fine. You know, you can reconstrain it. It's fairly reminiscent, and I don't know. It's definitely not the worst thing. But a lot of times you do end up having to do perpendicular constraints and parallel ones that you typically wouldn't have to bother with. So there are definitely drawbacks. So we'll set these to equal each other. And we'll do the same here. And look at that. It's already reared its head. So the overall is 0.5 plus 0.75. Or 0.25, which equals 0.75. And just because I don't know what we're going to be doing with this, I guess I'll just make this portion line to the center. Is that great? You know, I honestly don't know, but it's fine. It's 0.5 plus that, and then it's going to be extruded 0.5 both ways. And we'll add in our little cut and our second circle. Alright, so we can go ahead and do an extrude. There we go. And our circle is 0.313. Oh. And it's 2 overall, so 1.5 for this shaft. And then we need a chamfer of 1/16, aka 0.0625. Nice. Okay, so we can save that as connector. And let's jump into the handle. It's really basic. Shouldn't really take long. Okay, so I'm just going to shift this and trim. We'll slap some tangents on here. And we can trim out that. It's going to be 4 wide. And it's 0.25. And we're just locating things at this point. So let's go ahead and locate this thing in reference to the origin. I'm just going to use some vertical and horizontal constraints to tie it in. And then we will extrude at 0.25. Okay, so that's the handle. These parts are a lot easier than the other one, of course. Alright, so now we've got the joint plate. This one's definitely pretty wonky. It's going to take a little longer. Okay, so let's see. We've got, I think I'm going to use this bottom part. I have a feeling that's probably some crucial stuff, so I'm going to use that one as the origin point. And then I'm going to just copy it. We've got one up here, and then we've got like 3 kind of over this way, something like that. I'm just going to draw lines so I can connect it all. And this may seem silly, but it does help quite a bit, assuming everything's similar in size. Alright, so let's tie everything together. Ugh, gross. Okay. Are these all equal? Yes. Okay, so. Oh, that one's not. What in the world? Was it just ignoring me when I'm sitting there clicking constraints? Okay, so now let's do the same with the smaller holes. All right, we can put our tangents. So I mean, is it perfect? No, but you know, you get the idea. So I'm just going to extend where needed and trim where needed elsewhere. Let's make sure this one was extended already. It was, okay. Alright, so is that to scale? No, but it's not a bad start. So 0.25 and also 0.25. Turns out this is 0.25. It's a good thing because apparently I made some false assumptions there. Okay, so these two are vertically aligned. It's 0.75. It's 0.5 here. Make sure it's aligned. It's 0.5 from here to here. Same for here. So it's 60 here and 0.5 here. There we go. Okay. So you may be thinking, this 60 is between those. Yeah, that's true. But this line is parallel to the center lines, and this line is parallel to what would be the center lines here. So all I'm doing is condensing that a little bit and trying to save from having to draw extra. You could, but it's going to turn out the exact same way. So this is kind of the idea of just working smarter, not harder. Alright, so now I'll extrude that both ways and name this the joint plate. Alright, so next is V-link, and it looks super basic. But it's not actually all that basic. I like that. It's not, you know, symmetric here. The gap is varied, so that'll be a fun example. And I guess technically you could do half and mirror the other half, but parts that are simple like this, I like to kind of just get it all out there. But you're welcome to do it however you want. At the end of the day, it's not going to matter that much. And if you hate it, you can always redo it, you know? So, come on. Not to scale. Alright, so I'm going to trim these guys. So it's radius of 0.25, diameter of 0.25. Be careful of the typos. Make sure these 2 points are vertically aligned. And, you know, let's go ahead and align it with the origin while we're here. And I don't know what the intent is, but let's align these circles with the origin, and align the circle with the circle. Uh-oh. So we've had it invert. That's because we have yet to set these arcs to equal each other. Okay. So we need an angle of 138. And 0.75 for the width. It's a bit out there, ain't it? I could set it to be the same value. I'm just going to hit equals and set these to be the same because this part is symmetric. So why not? And we'll name that V-link after we extrude it, because I almost forgot about that. 25 V-link. There's quite a few parts to this one. All right, and let's see how to begin this one. So let's do this view here, and then it'll have to be quite a few features, so we'll just start with that. But we can just do a extrusion of a circle. Oops, wrong view though. The size is 0.5, and it's going to be 4 long. Okay, so we can go ahead and do the hole on the back side. That kind of seems like an easy one. Just put a point that is concentric to that circle, and then do the hole command. And it always defaults to the last size, so if yours is giant, you just gotta play with your settings first. So let's see, the hole itself is 5/16, and I'm not going to do threads, and I'll show you why once I get it set up right. All right, so if I do 5, that's the wrong value. What is that though? 5/16. So 1.75 here. Come on. Okay, so first of all, we want our drill point to be on, and the hole is 5/16. So basically, if I have it set here, now watch this. If it's set to be just the hole, watch the size, and watch it versus if I do a tapped hole. When I turn on tapped hole, it's still 5/16, but it changes the actual size of it. Now, I think this is Inventor trying to create some math saying this is the amount of material for a hole when you have threads and not. But I think that it's preferred, for visual representation's sake, to do the hole and then add the thread in. It sucks, but what else can you do if you want to have an accurate model? You pretty much are going to have to compensate for the fact that it tries to change the actual values of the model, even though it's not actually telling you that. So we're going to go in afterwards and do a thread command, and it's 5/16 10. It may or may not be in here. It ain't, so we'll just roll with the 5/16 18. And then we will do the hole cut. Come on, you. We'll slice graphics so we can see a little better. And that is going to be 0.25 off, and then 0.25 in size, and we need to locate it in reference to the origin. And there's our nice little hole we have drilled in. And we'll do a through all cut both ways. So now we need to do the top view. That's going to be 0.75 by 0.25. And then we can just go and project our edge, do a collinear. And it's crazy because looking at it, you probably couldn't tell that it was just a rectangular cut. That's all it is. You just extrude it both ways, and it gives you that shape that you probably didn't immediately pick up on. And just to make sure it looks right. Let's see, am I missing anything? I think not. Now, obviously this doesn't, well actually it does look pretty good, but if you want to see what it should look like compared to the other one, you can do a half section on the View tab, hit the checkbox after you choose the right plane, and now that looks like our guy. Now we've got to add some fillets still, but looks good. Okay, so I can just change that back to end section and do our chamfers that are a 1/16. Just to double check, I'm gonna look at it again. And unfortunately, if I would have done the chamfer earlier, we wouldn't have to do it on two edges, but it's fine. It still comes out fine. But obviously, you know it looks right in the end, so I don't need to section it again. And it's called rod. Okay, so I think this is the last one in our assembly. It is, and it's called bushing. So we'll start a new part, and let's do a revolution. I could do the chamfer, here, but again, I think it's nice to have the option to remove it pretty easily if you want. So I like to keep to more simplistic shapes when drawing where possible. Alright, so I like to usually do half values, but let's just do a center line. I need to get in the habit of using these more. They're a lot more helpful if you use them correctly instead of just spamming your drawings with them and whatnot. So it's going to be 0.625 in diameter. The hole itself is 0.5. And this portion is 0.125. With a 0.75 outside diameter. Alright, so we have an overall. Of 1.25. Okay, so then we need a chamfer. Same 1/16 as all the other parts. You gotta love consistency. Alright, so check our views, make sure it looks good. Nice, okay. Bushing, is that what it's called? Yeah. So let's go ahead and assemble it now. Alright, so given this is our base, I'm going to use it as a starting point. As always, try to choose a part that you can depend on that won't change its location. And if I've done my job right, it should just be as easy as hitting flush, flush, flush. Cool. Okay. So I'm going to pull some of this junk out of the way. And let's go ahead and save it before it gets too convoluted. I botched that. Okay. All right, let me just zoom in. It's really hard to see what's going on here. Well, let's just stick some pieces in and see what sticks. So first of all, I see there are 2 of these. Some copy and paste view in. And let's do an insert here. And an insert on this side. And I'm assuming that this portion is the perfect distance between these two. It appears so. I'm just going to make sure. Oops. Accidentally went too far there. Yeah, okay, so it fits perfect. But it actually goes to this 3rd hole, so I was looking at it wrong. Alright, so what I'm going to do is set these 2 to always be aligned with each other. So now when I pull one, they pull together. I'm going to move this guy over here and take a look. And it looks like it's constrained to that 3rd hole. So we'll do an insert to hole 3. And it looks something like that. Yeah. So then we can constrain the handle. It looks like the 2nd one goes here. And if it's modeled just perfectly, it should be as easy as doing a 2nd insert to the 2nd hole. That's why it's nice to be exact. You can, a lot of times, like doing an insert and an insert like that, it doesn't work because it locks the part completely. You have to be laser accurate to be able to achieve that. So it's usually a sign you're on the right track when you do see that. It works though. And I don't know if we'll be able to do inserts here. Yeah, that we can. Okay, I was worried because it's kind of oblique on part of it. So we can just do an insert here as well. And then a mate hopefully works. Yep, cool. So now it should actually be moving pretty decent. Okay. So it looks like this little lad inserts here. And last but not least, wait, is this supposed to have threads on the outside? Did I forget that? No threads, okay. I mean, it kind of looks like it would need threads there, but maybe I'm just overthinking it. Yeah, I mean, it clearly should be threads there. I'm going to go ahead and put the threads because clearly they should be there. So, is that the correct size? I don't know. Okay, so we're looking for the 5/16 10. Come on, what do you? So 5/16 is 0.3125. And it's saying, no, these are different sizes, I'm guessing, but that's fine. I'm just going to delete it, and then when I do the same thing from scratch, it'll be completely fine because threads are weird. Totally weird. Okay, you know what? It's not fine. That's fine. That's the size we need because it's 0.313. So I'm not going to worry that it has the inappropriate thread size notification. It's an inappropriate thread size if you ask me. Alright, so I'm just going to close a few of these. Okay. And it really appears that there's supposed to be a value given for the thread, but what we're going to do is just do the end of the screw inserted to the end of that hole and see where it lines up. Okay, so that's not viable. Come on. How is there not a value for this somewhere? Shame. This is one of those things where I'm assuming it used to be there in an old book and now it's not, and that's fine, I guess. It looks like it's just stuffed in there. So that's what we'll do. We'll just stuff it in, see where it lands. How about like an inch from the end? That's too far. Let's do half that. And that's fine. You know, obviously there's like limits to this. It doesn't really cover like doing joints, but what you would really want to do is have ranges of motion, like limitations. So like obviously I can flail it like this, but there should be a stopping point, and you can use the contact solver. There's different methods, and if you guys really want to get into that, I would love to talk about stuff like that. So that's one of those niche things that realistically it's not the end of the world, but it's really cool to know, and there's a lot of ways you can apply it once you do know that you can do stuff like that. So if that's something y'all are into, just let me know and we can work on getting some kind of something for that. Also, there should be like some rivets or something. That would be really cool here. Yeah, so what you could do is set a contact solver to happen. So like when you get to this point where it bumps right here, you could have that value pulled. And then you could have it do the same thing. So when you have whatever hits here first, I guess it's at this point right there, you could have that contact happen. And then you could have a range that it's limited to, and it would only go that far. But for the sake of this, it's fine. What I would like to do is set like a default position. So I am going to lock it down. So let's see what looks good here. For an assembly, I want to be able to generally see everything and get general ideas. So I kind of like that. Maybe a little further back. So let's do that. And let's just see like what angle it's at. I'm gonna turn on predict offset, and what that'll do is it'll tell me what that angle is. So now I see it's 99.85. So I'm gonna uncheck that because that's a horrible thing to have on. And I'm just gonna change this to 100 degrees. So now what you guys can do is just do the same options. Choose this solution for directed angle. Choose these faces, and it'll actually lock everything down just from that one constraint. So you know, it'll be easier to have uniformity if we all have our assemblies laid out the same way. So now we can go ahead and do our representations. Let's delete that default. And we have 1, 2, 3, 4, 5, 6, 7. 7 parts to do. So 2, 3. Okay. So we have pushing. All right, so there's all our ViewReps. So now we just got to go through and do the little isolate trick and lock each one down. It's quite a bit of work that goes into these, but you know, once you get in a habit of the routine you have to go through for all these petty little steps, you get pretty efficient at it. And is it fun? No. But once you get proficient, you can start to look for things to shorten your workflow. So like for instance this, I don't use it for you guys, but there is an iLogic rule that you can use that creates all these ViewReps with the click of a button. So once you appreciate the inefficient way, you can then start to use things like the iLogic rules that really help a lot. And the same can be said with like the planes. I actually don't go through and expand and mess with all these. I use a rule that toggles the planes and turns them on and off. And those are pretty useful. So we'll mess with more of that over time. So, so let's go ahead and make a position change by making a presentation and manipulating all of that. And let's go ahead and put on that shaded with edges because that's my life. Okay, so first and foremost, easiest things to remove, let's do first. So let's do tweak components for this guy. And I wonder if we can do, yeah, okay, so instead of doing a local means like in reference to this part. So like watch this gizmo. It's aligned. When I change it from local to world, it's based on, you know, the actual assembly. So I'm going to pull it over. And you know what, we'll pull it up a little bit too. Why not? And we'll hit the check mark so that it keeps all that. And I'll do the same here. I'm going to change it to world. And I'll pull it over. And, crap. That's okay. And out. Let's do the same here. World. Over. Am I being perfect about this? No. Not really. I could type in numbers and make it line up all fancy, but this is mostly just a demonstration for you guys, so I'll let you all work on getting that perfect. And I don't know what happened to that tweak, but let's just delete that. And we'll edit this one. Really don't know what happened there. That's pretty close. And then we'll tweak this one. And I like the idea of this one kind of like coming up and then over, something like that. It's not too bad. You know, we're going to be looking at it from this perspective, so being able to see everything is always a plus. And then I'm assuming this bushing is what really locks this part in place. So you would probably have to remove the bushing and a part together, but it's really hard to know without looking at like tolerances and sizing, and I'm not going to go into all that. So let's let's have, oh, it's tough to say. Yeah, okay, so we'll have these two come apart together. And then we'll have it come up. Okay. And then this portion we will tweak and have it come off of it. And this guy, we'll just bring it out. So yeah, you know, basically it's going to look like this in our isometric view, which is, I mean, it's fine. I mean, you get the point, basically. If I were to hit play, you know, obviously I didn't do any like timing on it, but it would slowly progress through the process. I don't know if I can speed it up. It would progress through the process of assembling and disassembling. So you get the point. I never mess with the slider because all I'm using this for really is an easy way to explode. But it is nice. So we're going to type in the same name but exploded. And then I'm going to put create drawing view. And what it'll do is Poop. Let's go back. Okay, so let's hit play. And I guess if I go to the end, actually, yeah, that's what I want to be at, is the end. So where the green is, that's when it's over. So now I want to hit save and do create drawing view. And it'll basically paste an image of it. What in the world? Why? I don't ever use these. I'm not lying. So, okay. How about instead we delete this view and let's hit capture camera. No, I thought that would do it. Okay, we'll just hit create drawing view again. If that's deleted, it won't pull view 1. It's going to pull a new view and it'll create it, and yeah, there you go. So conversely, you can do that. It's fine. So now we have toggle clamp. Why do I have to have that minus in there, you know? Like, it makes it such a pain. I have to hold the shift button the whole time I'm typing. I don't know about y'all, but I hated my caps lock so much that I kind of removed it. So, all right. So we got a parts list. And then we're going to go through and do the customary bubbling. And last but not least, I believe it's everything anyways. Yep, okay. So, you know, you would fill it out, all that good stuff. Save it. Gotta love that name, assembly drawing. Classic. Alright, so that's that. We close this guy down. And we can make our detailed drawing, and that'll be it. Now, granted, this is going to be a lengthy one, but, you know, we can get to it. I'm just going to look at our views we got and see what sticks. Ugh. Yeah, honestly, I mean, I don't really feel like we need these views, just this one. So what we're going to do instead is blow these up a bit. All right, the same deal. We'll just bubble everything. And obviously there's no wrong way to bubble, really. It's just whatever visually is apparent, you know? Whatever you can make work. I can't even remember. Is this the same part? It is. Okay. There's really not much you can give here. Like I did in the last one, I guess you could do some overall dimensions if you want. Maybe just to say, well, this is the maximum range you can get, or something to that effect. I guess one nice dimension you could have, you could dimension to that axis since it never changes. So like, for instance, what I'm going to do is make this epic center line, and then I'll dimension to that, because that is like kind of a good to know, I guess, you know, like here's where everything touches, right at 1.3. Okay, so I guess another one we could do as well would be that angle we had earlier. That's a complementary, but it works. Supplementary. Alright, so we can go through and make a million sheets. And let's see, a lot of detail here. Let's zoom this out a bit. So we have bushing, connector, handle. Oh, you know what? That's right. So we're going to do it in the order that we're given. So sheet metal base is 1. Connector is 2. Handle 3. Joint plate 4. V-link is 5. Rod is 6. Bushing 7. And save those overrides. We'll sort by item. Okay, so now that we're looking at that, let's just go through and name these sheets so it's easier to remember what we're typing. Assembly, because that's what we have on sheet 1. If you slow click, really not too slow, but kind of fast, you can rename it without having to wait forever, or right click. So that's what I'm doing there. Joint plate. Oh my gosh, I already forgot one. Okay, so I'm just going to pull this up here then. So we have sheet metal base, connector, handle, joint plate, V-link. Come on, you. Why you do that? Okay, so we have 2 more. Rod and bushing. Okay, well, page 1's done. Let's go ahead and save this in case we lose stuff. Alright, here we go with this hoss. What's cool is at least this one they kind of give you drawing-like items, so it's a little easier to replicate. Okay, so sheet metal base, make sure your box is checked. And I guess just for the sake of keeping it consistent, let's do the same views they give us. So, maybe 2 to 1. It's a little big, but let's do it. Oh, and another thing, so you may notice I'm having to fill out all these views. If you really know what you're doing with iLogic, you can also automate this. So like typically, I also don't manually type in all this information. It's automated, it's pulled. There's a lot of stuff you can do that it's hard to get into in these introductory classes, but I really think that with time, it's good to know that it's there at least. You don't have to be proficient at everything, but maybe one day you say, oh, I have a problem, and you know that there is a way to solve it. You're going to be more open to the idea, and you're going to investigate and research, and it's just good to know you have options. So just know iLogic's great, and it can cut out a lot of BS like this where you're just doing a lot of redundant filling work. So man, this thing's full of center lines, ain't it? Even have holes down there. And let's see. I'm not sure which one's which though. Okay, so it's actually this set. Let's see, so we've got these. Yeah, okay, so that should be all of our center marks and stuff. And it has its note on the top left, but we're going to do it in the bottom right. Alright, so number 11 gauge. This is one thing I feel like Inventor really still has a lot of ways to go. They haven't set this up to be like Word. I don't understand how we live in a world where everybody knows what Microsoft Office is, and they still don't have a damn good editing software, you know, for text or something, like whether it be an add-in or what. It's just a no-brainer to me. And we're going to put the right value, by the way. It's 0.05. But obviously, you know, they should have this on lock. It shouldn't have to be where you're having to hit space and manually format this thing. You should be able to have templates and all kinds of cool stuff. Maybe one day Autodesk will add it. Maybe people just don't complain about it, but I can't stand it. So I'm assuming it bothers other people too. And, you know, I'd be lying if I said I even know what OV round relief is. It made me wonder if it's a typo. But we'll roll with it. A little small. So let's change this to like 0.25. It seems good. Honestly, you know, it is too big. I should have stuck with the 1.5 earlier. I thought it might be fine, but it's too much. Okay, so I'm just gonna kind of just do the dimensions it gives and not waste too much time talking about it. I'm just gonna slap them in pretty quick, and we have a ways to go. So I'm gonna try, if you guys happen to catch some that don't, you know, I don't do it, make sure if it has 3 decimal places worth of value that you're adding that in. It's kind of a mixed bag on how it shows it, so we'll default to 2 unless otherwise, you know, noted. Alright, so what's cool about doing this, obviously, is, you know, I might be wrong when I get into this view. I'm a little nervous about it, if we're being honest, because I drew this for the first time with y'all, and I could be missing something. But that's what's really cool about detailing. Yes, it's miserable, but while doing it, you can often find the error in your ways. It's really good if you get efficient at it. You know, you can start to really pick up on some of the things that you could be doing wrong, or just catching things before you get yourself in trouble. You know, it's good to dimension. A lot of people hate it, but it's also what saves you from mistakes. So as long as you're being open to it, it's a great thing, really. But yeah, it's not going to be your favorite thing. And if it is, then, you know, good for you. I'm happy that you can enjoy this. It's not for everybody on detailing, but it is a large portion of what drafters do. I think a lot of people are in it for the creative part, you know, where you're making cool models that look neat, but you know, a lot of places this is like 50% of what you do. So it all just depends. But, you know, I definitely am not a detailer. Like back in the day, I would have loved the option just to model and have somebody else detail my work. And I think that some companies are kind of transitioning to that, you know, like trying to optimize people's time, because this is very redundant and slow. And for somebody with a lot of expertise, it feels useless, you know, like, why am I doing this? I'm getting paid this much money to just goof off, basically. It feels like it's, you know, it is what it is. I don't mean to go on a rant about it, but I'm not a fan of detailing. Okay, so that's it for this one. But we do need to bubble this guy. And we'll jump over to the next one. And I really like that they did these views. I can just straight copy them pretty effortlessly. Now this one I probably will do it 2-to-1. Yeah, might as well. And we're gonna start with the views it gave us. And we'll turn on the label, name it connector. It's still awfully small, but you know, I don't want to blow it up just gigantic. I like things to typically be similar in scale to the origin material. So all right, so we're given this value, and it should be 3 decimal places. Of course, we need a center mark. Some of the stuff they don't put, but you know, we're always going to try to add anything like that. And of course, in this case, it was there, but I'm just saying, always go above and beyond, even if you don't see it. All right. So we have this value, this guy, this one, and you know, to me, like, it makes no sense to have them staggered like that. If you're going to put one there, you leave all this open area if you don't have it there. It's a little more convenient. Sure, it's blocking it. This probably wouldn't be how I laid it out to begin with, but there's no reason to have dimensions all around the part. At a certain point, it makes it harder to read it quickly. So, and this one's going to be 2 decimal places changed to 3. And then we could add in a chamfer note like that, but that's a lot of work. So we're just going to do the actual chamfer command. And I'm going to hook it inside and hold control so it locks vertical. I'm just going to kind of slap it roughly in line with that 0.5. And it is really tiny. Dang, it's tiny. Okay, so we'll do 3 to 1. See how big it is. It's fine. And it'll scale the dimensions proportionally. They're not like usually perfect. Sometimes they get a little out there. So like if you notice, these are pretty spaced out. So you can pinch them in a little bit. And I guess now we'll just somewhat angle that. So, you know, I'm going to adjust these to make it similar to how it was. And then let's put in that ISO view. And we'll do a bubble. And something like that. It's pretty decent. All right, so now we've got the handle. Okay, and you may notice this is the first case where this pops up. This handle is aligned how the assembly had it. But we want it to look like it does in the book. So I'm going to hit on the view cube's little double arrow thing and hit custom view and choose look at. And I'm going to click this face. So what it does is it actually aligns to this face and it looks directly at it regardless of view cube. So I can right click this view cube and kind of cheat knowing that. Ironically, it's not giving me the option here to rotate. Usually you can set the view cube to usually set it to a new view right there, and it makes life easier, but I guess it's not going to let me. So what we'll do in this case is, now that we've got it set that way, we can just rotate it 90 degrees to the left, and that's going to give us our position that we're wanting, and we'll do the views it gave us. I guess we'll stick to that 3 to 1. I'm assuming that's a little big. Okay, so we'll do 2 to 1. Hidden lines on, turn on the view label, give it the name. And these are things you'll get in the habit of doing over and over again. So with time, you'll be choosing those options without even realizing it, really. All right, so we've got our bubble. And we've got thickness. I guess technically, yeah, we need a center mark here as well, or a center line. Ah, center mark. All right, so that one's pretty basic. So now we've got joint plate. And we've got the same issue here as well. So no biggie, we'll do custom view and orientation. And if any of these give us trouble, we can I just want to check this and see. Yeah. If any of these give us trouble, we can manually rotate the angles after a look at, but generally the look at is most of the time enough. So so let's do 3, and let's do a isometric view. And okay, so we may not be able to get all these center lines in here on the right, but we're going to try. So we've got that one, and always choose the larger circles. And if it's an incomplete circle, just go ahead and choose the inner afterwards. That way it kind of implies you've got some concentric circles going on there. It's good to know information. It'll really help somebody out. So, and then it looks like we've got, Lord, I don't even know. I'm gonna have to extend these over temporarily. So that is from here to here, and then this one is here to here. What's that? Okay, man, that's, yeah, I'm gonna leave those for a minute so I can put my center lines in. Sometimes it's really hard to tell. So we've got this one and the bottom one. Oh no, that's okay. And then I'm just going to delete this line, and it should be in line with it. Cool. Okay, so then same thing. It should be this one and this one. No, okay, it's this one and this one. Okay, so when I delete this, it should be there. All right, so now I'm just going to go back in and add those in because it's a lot easier to just re-add those. That's kind of one of those tricks, I guess, where you're just cheating the system. I don't know what else you can really do there besides just pull it over. It gets a little too tough to tell. All right, so we've got this value here, which should be 3 decimal places. We've got 0.5. And somehow I managed to not grab the end of that, so keep an eye out, make sure you're getting the actual tips. And as I mentioned before, you don't need that center line, but in this case, since it's pretty simple to pull it, we're going to actually add in that angled line. I didn't expect it to go quite like that, but I'm fine with that. I just did a center line command and actually pulled it. A lot of times it'll rotate it. So we'll slap in 60. It does make this dimension a heck of a lot easier to pull. Just line it up. And we'll type in 5 times in front of this. Put in our bubble. And we'll try to move this a little more proportionally in space. So maybe a little bit to the right. I mean, we have more open space here, but I don't want to get it too close to the title block portion down there in the bottom right. I'm going to save it real quick. We've been putting in a lot of work. All right, so V-link. All right, and let's do our custom view. Look at. Perfect. Okay, I forgot to project my other views, but that's all right. All right, so bubble. We got center marks. Just to make sure, so this second line is the edge. Just to make sure, I'm going to pull and it lines up. I wish they would just make these view labels default. I'm sure there's a setting like to default them further away from your view, but it's like you're always having to pull them away. I'm not sure why it's not just a native setting, you know? And you know what? I like the thicknesses up top. I've been trying to match, but it just doesn't have good flow that way. All right, so let's go on to rod. Let's try 3. We're gonna go back to 2. 2's fine. Okay, so let's do this view and that view. I don't want to lose my settings, so actually we're going to rotate it. So let's do a little rotation so it flips this to be the same position as the other one, and then we're going to do a section view. Hover over that midpoint and then just project from it, and that'll give us this view. And I still want the ISO. I'm a sucker for an ISO view. And fun fact, you can hit home to zoom out like I do every time when you're in a drawing. It does a different command when you're in a model or an assembly, but it is pretty useful. So, you know, I can just zoom in and hit home to quickly zoom to where you're seeing everything in one convenient position. So we need a center line. And even though you probably won't be able to see it, I like to be pretty methodical. So I'm going to draw it in just in case that section line is ever gone for whatever reason. And we've got the 0.5. I'm going to jump up here actually. I like the idea of also of dimensions being in line. It's a little easier for me at least to scan. So I'm going to position these a little different than the book, but I do like the idea of just labeling this thread. So I did mine a little different. I added an extra vertex in there. It works fine. There we go. 5/16, 10, UNC 3A. Yeah. Is that pretty? Not really. No, I actually hate it, but it's fine. I thought it would look better than it did in the in game. So yeah, it's fine. At least it's more legible up here. Do I like it? No, I don't. You know what? I'm just going to delete that leader portion, and then I'll just click Add Leader, and I will redo that. And I'll just move it down here. Okay, so now we've got this view. And it's going to be here, before I forget I'm going to do it, it's going to be here that I'm going to do my chamfer values. So for the heck of it, let's do 2 times again, just because I'm pretty sure that this was the one that I almost missed it on. So obviously it's pretty easy to miss. And we'll do our dimensions for this guy. Unfortunately, that's actually in the way, so that's why we're going to dimension it here and then pull this off the model. I always try to avoid dimensions on the model. Sometimes you really don't have a choice, but you know, you want to work in a civil way where possible. And we're missing a center line here. That's what I was worried about. Okay. Maybe we can do a bisector here. Perfect. Okay. Let's pull that out, give it a bubble. Okay. Not bad, not bad. Alright, so last but certainly not least is the bushing. You know what? That thing is really tiny. I think I will actually leave it at 4:1. But we're going to maintain the same positions we were given. And we'll do a section. So what you do is you click the view, you hover over that midpoint, which is a solid dark green like that, and then you just draw it, making sure it's horizontal. I realized I didn't cover it too well in depth earlier, but it is a pretty straightforward command, and you can always hover and it'll take you to a brief description where you can hit F1 to follow up to get further assistance on it. And you can always, of course, contact me, so I don't really worry too much about learning a command because we probably will cover it at some point if we haven't already. Okay, so once like this, we're going to have to manually put in that diameter value because it doesn't show. Oop. Change this precision to 3. So like we'll hit home, click that diameter value. Same deal. And I'm going to make sure to get that chamfered dimension in there. We're doing it up here. This is a much better position for it. So let's flip this. Get that there. And there's that. So yeah, that's actually going to be it for that part. So we can go ahead and save it, and let's flip to make sure there's nothing else I'm missing here. Yeah, so that's going to be it. All right, well, thanks for watching, everybody.